Triple integral in cylindrical coordinates. The definition of the cylindrical coordinates represent a point P here, in space by ordered triple r, theta, and also z. Okay, which r and theta are polar coordinates for the vertical projection of P on the xy plane, while the z is the rectangular vertical coordinates. Rectangular coordinates x, y, z are transformed into cylindrical coordinates r, theta, z by using this formula. If you see your x and then we just replace with r cos theta. If you see y, just replace with r sin theta. Z, just maintain it to be z. If you see x squared plus y squared, just replace with r squared. If you see tangent theta, just replace with y. The theorem here says that for our triple integrals in a cylindrical system, we have to integrate with respect to z first. Okay, and then later we differentiate with respect to over our region R. Okay, so dE you just replace with dr d theta. Okay, look at our graph here. We have the solid G. Okay, so this is our solid. Okay, so the top here, the z equals to k2. The bottom here, our z equals to k1. Okay, the projection from here, we have the shadow region R. Okay, so here is the double integral over region R, and then this first integral is with respect to z. Okay, this one should be the upper limit, this one should be lower limit. Why? Because k2 is greater than k1. Look at our example. Use triple integral in cylindrical coordinates to find the volume of the solid bounded by. Okay, so we have three equations here. So we have to sketch. Okay, the top here is the graph of the surface. Z equals to square root 25 minus x squared minus y squared. Okay, how do we get this? This is our okay, so z squared equals to 25 minus x squared minus y squared. So x squared plus y squared plus z squared equals to 5 squared. Okay, this is the equation of the sphere. Okay, with radius is to 5. Okay, since we have only the square root here, means it is hemisphere. Okay, there is our hemisphere here. Okay, so okay, 5 here, 5 here. Okay, so here is our hemisphere surface. Okay, next we focus on how to sketch x squared y squared equals to 9. Okay, here is x squared plus y squared equals to 3 squared, which is a circle with a radius 3. Okay, so here is our circle. Okay, since our system here is 3D graph, so we have to consider that the next okay, circle is up here whenever. Okay, next. Okay, so we have stacks of circle. Okay, stacks of circle here will build up to be a cylinder. Okay, is r equals to 3. Okay, last. Okay, for equation z equals to 0. Okay, our equation here represents xy plane. Okay, so xy plane. So in this case we have this. Okay, this is z equals to 0. Okay, so this is our solid G. Okay, so we project from above here, so we have our shadow here. Here is our region R. So here is our region R. Okay, so just transfer this one into this two-dimension system. Okay, so we have radius 3 here, So 3 here, negative 3 here. So 3 here, negative 3, 3 here. Okay, so we have our region R. Okay, so we have to think in polar system here. So we have R, we also have theta. So our R is from 0 to 3. Okay, our radius. And then for theta, okay, from here to here, which is 0 to 2 pi. Okay, now look at our triple integral here. Okay, so here we have to set what is our top surface, lower surface. Okay, so how do we get this? Okay, so we have 25 minus x squared. So you have to change it to 25 minus x squared plus y squared. So equals to 25 minus r squared. Okay, so you have to change by using the formula to this one. Okay, what about this one? Okay, so the lower surface we have z equals to 0. So just take this. Okay. Okay, now this one, dA. Okay, our dA we have to replace with r dr d theta. Okay, r dr d theta. Okay, our dr here, so this one is our r from 0 to 3. And this one is our theta from 0 to 2 pi. And then just integrate as usual. Okay, for this one we have to use by substitution. Okay, so just let u equals to 25 minus r squared. Okay, du over dr equals to negative 2r. Okay, just proceed as usual until you get your final answer to be this. Okay, finish.